Welcome to The Explainer. Today, we're diving into one of the most exciting frontiers in artificial intelligence, how we're finally building a real, persistent memory for AI agents, moving them from forgetful tools to truly intelligent partners.
So, here's what we're going to cover. First, we'll dig into the core problem with AI memory. Then we'll look at how new systems are actually modeled on the human brain, showcase the very latest breakthroughs, see their real-world impact, and finally, we'll peer into the future of this incredible tech.
All right, so let's jump right in. You know, for all their smarts, the biggest thing holding AI agents back has been, believe it or not, their terrible memory. And it's a question you've probably asked yourself, right? This isn't just, a minor bug. It's the fundamental wall that's kept them from actually learning from their experiences and evolving over time.
Okay, so think about it like this. Traditional AI memory is like talking to someone who completely forgets what you said 30 seconds ago. And that's not just frustrating, it leads to huge problems. You've got memory inflation, which means costs just go through the roof. And contextual degradation, that's just a fancy way of saying the AI completely loses the plot during a long task. The goal here is to bridge this huge gap, to give AI a memory that learns and adapts just like ours.
So how do we fix this? Well, the solution, it turns out, is to stop treating memory like some basic log file. Instead, we need to build something much more sophisticated, something modeled directly on the one we already know works pretty well, the human brain. And what's so cool about this new architecture is that it breaks down AI memory into different types, and each one has a very specific job. So we're not just throwing everything into one big data bucket anymore. This is a structured system, and it's designed to work a lot like our own brains do.
First up, you've got working memory. This is basically the AI's train of thought. It's all about the here and now. It holds on to what's happening right now in a conversation to make sure everything makes sense, just like your own short-term memory does when you're talking to a friend.
Next, you have episodic memory. You can think of this one as the agent's personal diary. It's all about hindsight. It recalls specific things that happened in the past, like, hey, the user liked this option last time, and uses that info to make better decisions now. It creates that all-important sense of continuity.
And then, and this is a big one, you have semantic memory. Just think of this as the AI's built-in encyclopedia. This is where all the general knowledge, the facts, the core concepts get stored. It's the foundation of expertise that lets an agent look at a totally new problem and know how to approach it.
So with this new brain-like structure in place, developers have been building some absolutely incredible frameworks. And they're giving these AI agents, which you can only really describe as memory superpowers.
Take the Mem0 framework. It's a fantastic example because it so brilliantly mimics how our own brains work. It doesn't just blindly save everything. No, it's smarter. It intelligently filters what's actually important, it lets the useless stuff fade away, and then it takes the really key insights and locks them into long-term storage.
And the result of being this smart about memory? Well, it's not just a small improvement. It's insanely efficient. Get this, we're talking a staggering 91% drop in computational overhead and over 90% savings in token costs. That is, without a doubt, a total game changer.
Now, what about when you have teams of AIs working together? Well, that's where the Intrinsic Memory Agents Framework, or IMA, comes in, and it is absolutely revolutionary. It gives every single agent on the team its own specialized memory that's perfectly aligned with its job. This makes sure the whole team works together like a well-oiled machine, without losing context or, stepping on each other's toes.
And the impact? It's not subtle. You can see it right here. In really complex planning tasks, these IMA-powered agents get a nearly 39% performance boost over the standard ones. And they do it while being more token efficient, so you're getting much better results for less cost. It's a win-win.
Some of these systems use this really clever mechanism called intelligent decay, and it's all driven by this utility score function you see here. Now, I know the formula looks a little intimidating, but the idea behind it is actually super elegant. It just calculates how valuable a memory is based on three things: how recent it is, how relevant it is, and, this is the cool part, a special utility score. A human can actually go in and flag certain information as critical, so the AI knows to never forget it. And then you've got something called AsMem, which, wow, this is really next-level stuff. It basically acts like a self-organizing notebook. It's not just storing facts in isolation, it's actively creating links between them over time. This is huge because it solves what's called the island problem, where you have all these related ideas but they're just floating around, disconnected.
As Mem builds bridges between those islands, and that allows the AI to start seeing the bigger picture and discovering high-level patterns all by itself. Okay, so this isn't just theory or stuff that's stuck in a research lab. This tech is already out in the real world and making a massive, massive impact. Let's take a look at a few examples that show just how much this is already changing the game. Take customer support. An AI agent that actually remembers your history with the company? That's a total revelation. They're boosting the number of cases an agent can handle per hour by 340%. And look at this, they're cutting the average time it takes to solve a problem from a painful 18 minutes down to just over 3. That's huge.
But the stakes get even higher when you look at healthcare. In this field, agents that have both procedural and episodic memory are hitting 98% accuracy on really complex diagnostic tasks, like spotting tuberculosis in X-rays. And they do it in seconds. On top of that, it's helping drive down administrative costs by up to 30%.
And of course, in the super fast-paced world of finance, optimizing memory is absolutely critical. One company in financial services saw 95% improvement in their query response times just by implementing a smarter memory system. And what happens when customers get answers faster? Well, their satisfaction scores jumped by 20%.
So, yeah, these results are incredible. But the really exciting part? This is just the beginning. Where we're going with AI memory, it's heading in some directions that are, frankly, mind-blowing.
The next giant leap forward is all about the deep integration of something called knowledge graphs. This is what's going to let an AI move past just spitting out facts. It'll allow them to truly understand the relationships between those facts. It creates what you could call a verifiable memory and map of everything it knows.
What we're looking at is a future of perpetual learning, where these AI systems can evolve all by themselves. Think about a universal memory passport that lets an AI share what it knows across completely different platforms. And imagine a future where reasoning isn't some separate process. It's just woven right into the fabric of memory itself.
And that brings us to one final, really provocative question to think about. What happens when an AI's memory isn't just permanent, but it's also interconnected, self-organizing, and shared everywhere? As we build AIs with memories that can learn and adapt, maybe even better than our own, what does that mean for our world? How is that going to reshape everything?